Next up is Lukas Gubo, MLOps project manager at Virufy, where he ensures the proper delivery of robust ML pipelines and milestones by various teams. He's here today to share how his strategy is to deploy robust but explainable models by using several open source tools to help with model development, and how he counts on those tools to make a streamlined process for deploying models. Take it away, Lukas.
Hi everyone, my name is Lukas Gubo. I'm project manager in the MLOps division at Virufy. Virufy is a non-profit organization where we are trying to solve problems with the technology. All people across the nation should have access to an affordable and fast and paced healthcare. So we are using technology to do this. With this help, I would like to kind of walk you over our development strategies and kind of explain how we do our MLOps approach at a Virufy. So since AI development in the Agile world is not fully adept, we created our own strategy at Virufy. So the main thing or the most important thing is the collaboration. Since we are a non-profit, we have multiple people across multiple locations. So therefore, the collaboration with people is very important. So our team consists mainly of engineers and business professionals, and this is very important to make sure that both sides are talking to the same language. We develop our own process where each stakeholder of specific model or specific requirement is part of our planning. So the planning takes place on every 2 weeks, and we go and start our sprints, and then we develop the requirements as needed. This way, the business team as well as the engineers can be on the same page and talk through any open topics which they might have. So once we know what, then we can proceed to the next phase where where can we get the data and process them for our model development. This phase, we concentrate mainly on the problems to solve the business requirement and create a small POC. So the small POCs can be something which doesn't work, also refer to MVP as a viable product, and try to identify algorithm which will be used, and while other teams are concentrating on the data engineering and building the initial concept of machine learning pipeline. Yeah, so those are the two main topics which we cover during the model development, and we are trying to automate as most work as possible. So every experiment can be run multiple times with different parameters and over on a fast kind of paced fashion, so that we don't waste our time and don't use the costly time of our data scientists. So as I mentioned before, automating is our main key, and automation plays a key role in our process. While we try to run as many different scenarios as possible, without this automation, it it would without this automation, we would be doing only manual process, which is performed mostly in the early stage of the steps. So this step would be would would be executed in a Google Colab or as a simple Jupyter notebook. But more advanced, but still not the full blown automated process would be a machine learning pipeline. Here, we can schedule automated model training based on the hyperparameters, or even retrain the previously trained model based on a model or data drift. So every time there is a new change or update needed, then it will trigger the retraining. But to fully connect those key components, the data, machine learning, model, and testing, a CI/CD pipeline comes to place. Similar to a software development technique, it is needed to understand the difference where machine learning CI/CD is different from this approach. Here we have multiple revisions, which is needed for the model, and multiple stakeholders come together to review the model. This pipeline builds our business logic, it tests it at the end, and deploys to an endpoint, which can be consumed by the application. So the operation part is also very important in this whole life cycle of machine learning. It is very critical to stay on top of what the model is doing and what is the performance of the model, if it matches the requirement of the business. So the main areas which we monitor are model quality. We monitor the performance of a model by comparing the prediction which the model makes with the actual ground truth label that the model attempts to predict. So to do this, the model quality monitoring merges this data that is captured from real-time inference with the actual label that we store either in a feature store of a cloud provider or could be also somewhere on-prem. Then another aspect is the data quality. The data in the real-time inference is usually not carefully created like most training data sets. Therefore, this is important to be notified when there is a data drift or the issue arises. So the next will be the model bias drift occurs when the accuracy of the prediction produced from new input values drifts from the performance during the training period. So it's similar to a data drift. We can get notified on the model drift when the performance is not well. Then the feature drift. So it's more driven a feature distribution of live data for models in production, but this can also result in a corresponding drift in the feature attribution values, just as it could be cause a drift in bias when monitoring bias metrics. So again, all these components ties together, and these needs to be monitored, and they are very crucial for us to deliver the current model and make sure that it's performant. So the main key or the main differences between the MLOps, you need to be, as an MLOps project manager and a standard regular software project manager, need to be creative. You need to collaborate between all these teams and accommodate all these business requirements which might come along the software, the model development. It is very crucial to iterate fast over small many POCs, where this is the key to deliver the product. So you iterate it multiple times, whereas more software is more straightforward development. Even if you would try to buy a software which would help us with our machine learning development, it wouldn't be much helpful because everything is about the data. So it's data-driven development based on the business requirements. The next thing you might face as a machine learning project manager is creating and connecting the teams all together. So breaking the silos between the data analyst, machine learning, and the software engineer is important. It will ensure that there is a seamless flow from design to a production. While machine learning engineers create an algorithm, they need to be close contact with the software engineers or DevOps in our case, which is the majority of our team in an operational side. So they will start planning CI/CD pipelines, so they understand how the model works, and DevOps team can ensure that they can deploy it to their stage and test it appropriate. So this would include just unit testing of the code, and then at the end deployment. During this whole phase, once we have this model deployed, we would collect the data through the inference, and we can also create a continuous training pipeline, which we are currently working on to ensure that new data coming through which are coming through would automatically retrain the model if there is a needed. We will create an automated gateway, which based on the metrics, AOC or sensitivity metrics, would then approve the model and to be deployed to production as needed. So the communication is very important. So we split up this way also our teams to make sure the data science team has also the knowledge from the operational perspective, because data science team or data scientist usually doesn't have the IT background. So what we are trying to do, we are combining those teams together. So this is also called machine learning engineer. So it's a pretty fairly new position, which includes both knowledge of the software development and the data science. So these skills are combined together, where data science, as I mentioned before, doesn't have most of the time the knowledge of about automation tools, Git or CI/CD pipelines. This will help us pretty much to set up the whole life cycle where we start from an ideation phase, and this is still very similar to a project manager best practices. Then we move to the data acquisition phase, and once we establish the process and best practices for the team, this can be then tracked in a simple way, which can be then shown to the business team. We would identify the data sets which we need and confirm how we can get them and clean them and just do the standard ETL process. In parallel, we would run also the research and development phase. It's very critical how to manage it about this one, because you want to make sure that you keep track of all these kind of research, what you've done, and everything what you created. So to start, we will need to be able to monitor each experiment, and each experiment can bring us a business value in and only if sells. So we would be documenting each findings, sources, and failures, and all these assumptions. These findings will keep the business team interested and engaged, so we can provide feedback, and they can provide the feedback back to us. And also, we try to adding also some time-based check-ins during this phase to ensure we still want to continue with a specific problem. So if we are spending, let's say, 6 months on the model, it's because we are still getting a good insight and business value. So there is a constant feedback, and you can never like overly communicate. There is always more communication needed. So then the next step, we would then have a validation kind of life cycle step. And this in theory would just be a final sign off, because we, or I as a PM, should be bringing the findings from the research and development phase to business stakeholders through this phase. So once we have confirmed, yes, this works, then we need to again communicate to the business team to ensure this is what we need and this is what we got. Then the last step, but not least, will be the deployment phase. Since we have already modeled something built, we would be using a simple approach, which will be the waterfall, which then can easily follow the predictive workflow, because once we deploy, this is what happens next. And the last phase in this life cycle, where we are trying to build and still building, because AI is still developing, will be the monitoring phase. This is going to be the little bit interesting phase, because we'll have to decide who is responsible for tracking actions from all these monitoring metrics, which we collect in either cloud or as on-prem. Then we would have to have multiple teams which will take the reports and agreed on the maintenance of the project, which are fit to the overall team's priorities. So each kind of team will have a little bit after work. So AI will never, or the model itself will be never done once we finish developing. And Yeah, and one thing I would like to mention is also the agile approach, which we are trying to still adapt. Agile in general is very iterative, but what we find out, it's not iterative enough because in a software development, yes, you have A to B kind of path, but those principles are not agile enough for model development. In generally, agile principles apply to data science, but like I mentioned, it needs to be adapted extremely to be in kind of iterative nature of a data science. Agile methods are supposed to be iterative in this case, but are often considered not iterative enough for our data science approach. Meaning, in other words, agile is not agile enough. Of course, the extremely iterative nature of AI and machine learning projects is that the models are actually applications as a whole, and they are automatically generated by the machines. So they can crank out many more model iteration experiments in a short time span than a human could ever do. Another challenge I would think what during this whole development and managing this whole life cycle is that the work product is not just an application. It's more about also the data. Where is it coming from? What kind of type of data it is? How to process it? So Agile was created as an application development, but not a data development. So then on the other side, the data projects have not always fit well with the agile methods, as the data projects tend to actually be less iterative, take longer time to research them, make data manipulation, and this often leads to more use of traditional waterfall project management methods. So it's more adaptable to waterfall than the agile approach.